the least emergency fund should be in your hands. Anything can happen anytime. Don't say, "So I'm not with anything." After you enter a straight line, don't know anybody, I'm not with anything. Anything can happen anytime. The least 1 or 2K emergency fund. Anything can. We were in school, which set was that when I was a student, I finished in the pot. We were in school one day. I don't know what happened. Follow this. They were shooting some armed robber or something, so they were pursuing them from this is West Road. That was set back then. So the armed robbers didn't know where to enter, then I ran and entered inside school. School was scattered, you see, gone. People started looking for any shot to just drop, I'll pay. Some people escape through the gate. Some may I fly, enter one place. You understand? You don't have emergency points. It's my first time carrying it. It's a risk to be moving around and it's a very big one. I have emergency. So I just can't play. So you don't have I said maybe this one thing I don't have. Don't enter that. Anything can happen. It's a strange land. Something happens. I say, pay for this land, and I say, no, you have emergency. Don't spend all your money completely. When I was in school, I will keep it. Anything can happen in school. My parents are in park in the West. What they say to pay for this land, and I don't have anything. Have emergency. Have emergency fund. At least this one was okay. Anything can happen, I want to run away from the school, drop. Or you need to run, there's an emergency. You need to move out, and you don't have this one, it's bad as well. Keep it inside your wallet, inside the nucleus of the atom. Inside the what? Keep within the what? Nucleus. How you work cannot this one in case of anything, balance the power. If you get class, one small thing that you don't have to put in your home, or you don't know, guys, you know, I think this is I'm already, I didn't really know what that. This is what? Very, very. Balance the following equation. K2CO3. Balance the following equation. K2CO3 plus Al2Cl6 plus Al2Cl6. K2CO3. K2 what? Plus Al2Cl6. To give Al2 open bracket CO3 into bracket 3 Cl6 to give Al2 open bracket CO3 into bracket 3 to give what? Al2 CO3 into bracket what? 3 plus KCl plus KCl. Class, that's the class of life. Cl6 plus what? To give this arrow, right? Al2 to give what? Al open bracket CO3 into bracket 3. Al2 then open bracket CO3 open bracket Al2 then open bracket CO3 close the bracket into bracket 3. That is Al. Alright class. Nice. First answer yes. Hello.
Look at this one, please.
Who's done again? Intelligent student, very intelligent, very what? Very intelligent student. If I narrate up there, just call my name. Are you actually done? Okay, she has written solution. Good. plus Al2Cl6 to give Al2CO33 plus Kc. Follow me. Let's go. K2CO3 plus Al2Cl6 to give Al2CO33 plus KCl. Class, don't forget the first step. Those that came in later and said, please, I'm lost. So follow now. Step 1 is ascribe unknown letters to each component. A, B, C, D. Ascribe unknown letters to each component of the reaction. A, B, C. Let A be equal to. Now, form an equation for every element in the reaction. Who are the elements in the reaction? K, C, O, Al. This one has lots of equations. Every element in the reaction must form an equation for it. So step 1 again says, ascribe what? Unknown letters or alphabets to each component of the reaction. So this is A, B, C, D. Ascribe unknown letters or alphabets to each component of the reaction. And let A be equal to. Form an equation for each element in the reaction. Form an equation for each element in the what? Class, let's start with potassium. K is potassium, right? Potassium is 2 times A. 2A. On the left hand side, potassium is 2A. Follow carefully. 2 what? A. Now equals to, now go to the right hand. What's potassium on the right hand side? D. 2A equals to D. That is the equation for potassium. Let's go to carbon. What is the equation for carbon? This A also affects carbon, right? A equals to on the right hand side. Class, let's be very careful. This C is inside a bracket that contains 3. 3C. 3 what? Carbon is C number, but this C covers carbon, right? But this 3 also covers carbon in the bracket. So 3 times C. 3C. 3. That is the equation for carbon. Oxygen. 3 times A equals to. Class, 3 times 3, 9. 3 times 3. O3, but another 3 outside. 3 times 3. 9 times C. 3A equals to 9. Are we following, class? Yes. Is it making sense? Small now. Yes. Let's go. Aluminium, 2 times A. So 2 times B. 2B. Aluminium is 2B. Follow me. What of this side? 2C. 2B equals to 2C. Now the last one, chlorine. B times 6. 6B. Thank you. Equals to D equals to what? Class, we have just formed an equation for every element in the reaction. We have just formed an equation for every element in the reaction. We have just formed an equation for every element in the what? Reaction. Good. Don't forget, let A be equal to. Class, what we'll now do is this. Solve the equations, right? Solve the equations. 2A equals to D implies that 2 times 1 equals to D because A is 1, remember. A is what? 1. Remember, we said let A be equal to 1. So 2 times 1 equals to D. What's 2 times 1? 2 equals to D means D equals to 2. D equals to what? 2. So A is 1, D is 2, D is. Now let's keep going. Follow me. A equals to 3C. A equals to 3. But A is 1, remember. So 1 equals to 3. How do we make C from the Bible side by? 3. So that C is 1 over 3, right? Class, we already have one of our values of a fraction. We know what that means. A is equals to 3. Someone said come again. I heard someone come again, right? A equals to 3C. And A is 1. So 1 equals to 3. Because A is 1, remember. A is. So 1 equals to 3. If 1 is 3C, can we make C straight for the formula? C must be 1 over 3. C must be what? Now 3A equals to 9C. 3A equals to what? But A is. So we already have A and C. So this equation does not give us anything. We don't need to solve this equation because we already have A and A is 1, C is 1 over 3. No need to solve this equation. The two unknowns. The essence of solving an equation is to get the unknowns, right? Yes. We already know A and C. Let's solve this one. For this unknown that we don't know B, right? 2B equals to 2C. 2B equals to 2C. But who is C? So 2B equals to 2 times 1 over 3. Do you agree? So that 2b equals to 2 times 1 over 3, 2 over, can we cross multiply? 3 times 2b, 6b equals to 2. Can we divide this side by 6? 2 here. So b is also 1 over, b is also 1 over. Class, as soon as we've gotten this equation side, you don't need to follow me to solve. You can solve it yourself in your book, right? As long as you can get this equation side, just use A is 1 and start solving D. A is 1, start solving C. This one we already have A and C. Here, C is 1 over 3. Solve this. So at this point, you're not allowed not to understand because it's just equation they are solving here. Where you might not understand, if you say you don't understand how we got the equations. But once we got into the equation, normally you can choose to solve normal simple algebra equations. Since you know one of the unknowns as 1, right? 2 times 1. So you can do it at your own pace in case it's looking a bit tedious because you're doing it on the board. You can do it at your own pace. A is 1. Just use slow, okay? I don't want to rush as they're rushing the class. A is 1. Put 1 here. 2 times 1, 2. It means that D equals to, let me do my own small sum. Okay, A is 1 again. 1 equals to 3. Okay, make 6 out of the. At this point, you want to get this result. Now, we got B as 1 over 3. Let's do the last one to get D, right? If B is 1 over 3, replace B with 1 over. We've gotten D. D is what? Questions on algebra. Used as assignment. Can I go to ionic equation now? How to balance ionic equation. Let's go. How to balance what? Ionic. So use this one now to demystify all your assignments. Use your assignments as more class for practice. Remember what I said about your brain? Practice. Keep giving your brain that I need this thing stored. I need this thing stored. Telling your brain I need this thing stored. Store it for me. Ask more questions. Practice it. Force your brain to store it. Thank you, my friend. Yes. Yes, he is on the transport. Yes. He said yes. Why was oxygen stored? Why was oxygen That's why we didn't bother solving it again. The two people in the equation, A and C, we know them. We already got A as 1 and C as 1 over. Thank you. Was that your question too? Can we substitute both? Definitely. Now, but it will work for ionic. That's not ionic now. It will work for balancing of ionic equation. Right, 1. You say? Right? They are. We should be getting easy as we are solving more questions now. And let A be equal to. Check, some of you have not even read this thing, you've not revised it yet, but you're already getting into what the next steps. So your brain is repeating it, it's now storing, your brain is storing it. What's the next step? You know it now. Form equation for each of the elements, right? Because you are repeating it, practice makes N 2A, right? H equals to 3. But A is 1, remember. So replace A as 1, 2 times 1. So 6. Come here and replace C as 2, right? 2b equals to 3 times 2b equals 3 times 2. Divide both sides by 6 divided by 2. So A is 1, C is 2, B is. You see, there's not every time we will lead to a fraction. This one is not stress. A is 1, so A is 1 NH2. B is 3 plus 3H to give C is what? 2. 2 NH. Who got this before I got it? You got it actually. I'm happy. Most students got it. That's good. Those that don't got it, I'm assuming you got it, but your hand is spinning it, right? Yes, I understand. You got it, but your hand is spinning, so let me not stress now. I got this too. Leave on. Class, so by now you have gotten to inspection and algebra.
Come on, like question.
You see? It was only N, but you are asking me. Only N here. Yes. In the main question, I cannot put N, I put N for N. Your slot is over, Sha. You have asked 3 questions today. You have finished your slot, so I will not waste time. Now, balancing ionic equations. Sorry, see? Yes, the half reaction method. They are correct. The half reaction. So please, the guys, that update I gave you, if you want practicals, maybe tomorrow we can go. I'll just show you one Sunday. Then you take over from there. Are we together? I'll follow you tomorrow. We'll go together. See the magic. Draw where suit. It's called that reaction method. You must divide the equation into two halves. You must break down the equation into two. One is oxidation half, the other is reduction. Give me this chemistry test. Give me this chemistry test. Now we are looking at half reaction method of balancing chemical equation. Why are you laughing? I don't mind them. Now we want to look at half reaction method. Some of you are stingy with your subscribe button. Subscribe is free of charge. Click on the subscribe button so that if I post any video on our YouTube channel, you can see the videos. When you click subscribe button and you turn on notification, turn on the notification on YouTube. Anytime I post a video on my YouTube channel, you see it. You do what? You see the videos. Okay, I posted something on chemical balance, you see it there. So subscribe to our YouTube channel so that subsequent videos like this that can help you, you can see them. But most importantly, make sure you are coming to class. Physical class, nothing as good as physical class, where they're explaining to you one after the other. Now we're trying to look for questions on balancing ionic equation. Let us take this question down quickly. MnO4 minus, please. MnO4 minus plus H plus Fe2 plus to give Mn2 plus Fe3 plus H2O. Stop with that, okay, no noise. Class. No noise, no noise. Class, see that this one is not a child's play, it's not on my equation. You can see ions on top. Pay close attention. Pay close. Now class, there's what we call oxidation and reduction in chemistry. Follow me carefully. Oxidation has 4 definitions. Reduction has 4. Oxidation has occurred if one or more of these following 4 things are happened. Number 1, if there's been an addition of oxygen. Follow me. If there has been an addition of oxygen, oxidation has occurred. If there has been a removal of hydrogen, oxidation has also. If there's been an increase in oxidation number, oxidation has occurred. And if there's been a loss of electron. So oxidation has 4 different. Why am I teaching you oxidation? Because class, I want to break this reaction into oxidation half and reduction half. That's why it's called half reaction method. Class, the first step in balancing any ionic equation is to split the equation into 2 halves. One half is where oxidation is taking place. The other half is where reduction is taking. Because class, we have types of reactions. All ionic equations are under the type of reaction that we call redox reaction. Class, as long as there are ions in a reaction, it means that oxidation and reduction is taking place simultaneously in that reaction. Please follow carefully. If you watch me, I can play a lot. When I'm serious, I'm also very serious. That's one thing about me. If I'm playing, I will play. When I'm serious, I'm also very. That's that like all work without play. Make jacket or all play without work. Make jacket very foolish. You understand? All work without play. Make jacket or all play without work. Make jacket what? Very foolish boy. So class, follow me. Oxidation has 4 definitions. Follow me now. 1, addition of. Follow me. 2, removal of. 3, increase. 4, loss of. Class, if an element has lost electron, oxidation has occurred. If an element has increased oxidation number, oxidation has. Let me show you an example of someone increasing oxidation number. Class, what is oxidation number? Is the charge an element is carrying. Oxidation number of this ion Fe is 2 plus. From the left hand side is 2 plus, right hand side is 3. It shows that there's an increase in the oxidation. Therefore, ion has been oxidized. Therefore, ion has a what? Because class, it's not every time you notice addition of oxygen. Class, without this understanding now, we will not know if ion has been oxidized or not. If you're only using addition of oxygen or removal of hydrogen, you will never know for ion because ion doesn't show any loss or gain of hydrogen or oxygen, right? So when you don't see any noticeable change in oxygen or hydrogen level, we use oxidation number. When we cannot use oxidation number, we now go to electron as the person lost or gained electrons. Class, are you aware that when sodium Na is 281, sodium is number 11 on the element table. When sodium all of a sudden becomes Na plus 28, it has actually been reduced. It has been what? Because, okay, it has been oxidized, so it has been oxidized. It has been, oxidation number here is 0, oxidation number here is plus 1. It has been oxidized. Plus, every element that does not have any charge on it, it means that oxidation number is 0. Oxidation number is, when an element does not show any charge, the oxidation number is 0. The oxidation number is, but this from 0 to plus 1 means that sodium has been oxidized. But class, oftentimes are not. When someone has increased oxidation number, he always loses electron. Increased oxidation number means loss of. Look at this now. From 0 to plus 1, oxidation number has increased, right? But look at number of electrons. From 281 means 11 electrons. It has reduced to what? 28. So even though oxidation number has increased, number of electrons have reduced. So anytime there's an increase in oxidation number, there's a loss of. But look at the definition of reduction. Class, once you can understand this and this, our pieces are ionic now. Follow me. This is the foundation of ionic equation. Follow me. Reduction is addition of hydrogen. Anytime an element has added hydrogen, it has been reduced, has been, or removal of oxygen. Anytime an element has lost oxygen, it has been reduced. 3 is just the opposite of this, right? Decrease oxidation. Anytime there is a decrease oxidation number, there will be a gain of electron, a gain of. So while in oxidation is increased oxidation number, there is loss of electron. For oxidation, there is increased oxidation number, there is loss of. But for reduction, there is decreased oxidation number, there is gain of. Class, quickly. Because if you cannot identify oxidation and reduction, you cannot split this equation into oxidation and reduction half. Class, follow me. Your ability to understand the concept of oxidation and reduction will enable you to be able to split the equation into oxidation half and reduction. Because oxidation half means that it's the half of the reaction where oxidation is taking place, and reduction half is the half of the reaction where reduction is taking place. So if you don't know where oxidation is taking place, how can you know the oxidation half and how can you know the reduction? That's why it's important to understand what is oxidation. So I'm going to divide this equation into two now. I will divide this equation into, the first step in solving an ionic equation is to divide the equation into two. Oxidation half and reduction. The oxidation half is where oxidation is taking place. Reduction half is where the reduction is taking place. So it's someone that understands oxidation that will be able to bring out the oxidation part, right? It's someone that understands reduction that will be able to bring out the reduction. Class, if you watch this Mn add 4 oxygen. All of a sudden, it doesn't have any oxygen again. What happened to him? When someone loses oxygen, what has happened to him? Has he been reduced or oxidized? Reduced, right? Because you now understand that reduction means removal of oxygen or loss of oxygen. Oxygen has been removed from NMNO4 to become Mn2+. It means that this guy will form a reduction half. So I now have my oxidation half, my reduction half. Class, look, my oxidation half is Fe2+ to give Fe3. Why did I call this my oxidation half? Oxidation number increased from 2+ to what? Therefore, this is my oxidation half. Any of your friend that is not here, show them you know they will be lost. If they have not learned, I said they know it before. Someone that doesn't know this before. Don't want to say, let me just say the note now, I understand. Because it's more complicated. But even you in class, I'm sure, still have some challenges. 2+ has increased to 3+. Oxidation number has moved from 2+ to 3. And when that happens, there's the increase in oxidation number. So this is oxidation half, right? Look at my reduction half. My reduction half is where reduction is taking place. Mn to give what? Someone asked me a question, sir. Are you not seeing hydrogen, sir? Are you not seeing water? We didn't do them. What happened to Of course, if you have to add hydrogen and water, it's clear that you can even say hydrogen was oxidized. Because this normal hydrogen has not been oxidized to what? So it was oxidized, right? So if we are to add it, we're going to add it to the what? Oxidation. We're going to add it to the what? Oxidation. Look, hydrogen is also oxidized, right? We're going to say Fe2 plus H plus to give what? Fe3 plus H2O. But class, it's not, I don't even need to add H plus and H2O. Do you know why? While balancing chemical equation, H plus and H2O will eventually come back into the equation. Follow me carefully. When balancing chemical equation, H plus and H2O will eventually come. I'll tell you how. But class, when balancing chemical equation, for every molecule of water, for every oxygen in a reaction, we add water. Class, what we use to balance oxygen is water. What we use to balance oxygen is what? And what we use to balance hydrogen is H plus H. So class, I could do it like this, or I could also not do it like, class, I can clean this H2 and H plus now, and just write Fe2 plus and MnO for this. Class, when you have balanced chemical equation, ionic, you can neglect the H plus and the H2, that's what I'm saying, because they will eventually come back. Because they are one of the major tools we use in balancing ionic. They are one of the major tools we use in balancing ionic equation. They will definitely come back. They will come back. Class, watch. See how they will come back. Class, why ionic equation is more difficult than that? You are not just balancing atoms, now you are balancing charges. You are balancing what? Class, this equation is not balanced. We have one ion here, we have one ion here. But it's not balanced electronically because or charge-wise. No, we have 2 plus here, we have 3 plus here. In balancing the ionic equation, for the equation to be completely balanced, both the number of atoms must be balanced and the charges must also be. How do we balance charges? We use electrons to balance charges. We use electrons to balance charges. First and foremost, class, ensure the number of atoms are balanced first before charges. Ensure the number of atoms are balanced first before. Class, looking at this reaction, number of atoms is balanced. Number of atoms is what? So we have Fe, we have F. Follow carefully. This is not a time for your friend from the village to be talking to you. Follow what? Fe 2 plus, Fe 3 plus. Fe is balanced, but 2 plus and 3 plus. Something is not balanced, right? Class, this 3 plus must be reduced to 2 plus. How do we do it? By adding 1 electron. Class, if I add 1 electron to this, electrons are negatively. So class, if we have 3 plus here, for this 3 plus means 3 plus, right? And I add 1 electron, 1 minus. 1 minus to cancel 1 plus, meaning up to how many plus? And the number of plus here is now equal to the number of plus. So we use electrons to balance charges. We use electrons to balance what? We use electrons to balance charges. Class, so now this reaction is now balanced both atomically and ionically. This reaction is now balanced both atomic, atom, 1 atom of Fe, 1 atom of F, and charges also. Let's come to this side. Balance atoms first before charges. Balance atoms first before. Mn is balanced, Mn is. But O4 is there, there's no O4 here, right? Class, to balance oxygen, for every atom of oxygen, you add 1 molecule of water. Add 1 molecule of what? Now, because we have 4 oxygens, we're going to have 4 molecules of water, 4 H2O. You can note it down. For every oxygen atom on the one side, add the equivalent number of water molecule on the other side. For every oxygen atom on one side, add equivalent number of what? Water on the other side. For every oxygen atom on one side, add the equivalent number of water on the other. For every oxygen atom on one side, add the equivalent number of what? Water molecule on the other. So I have O4, right? Because I have 4 oxygens, I added 4 H2O. We use water to balance oxygen, class. If there's 4 oxygen here, I'm going to add 4 molecules of water on this side to balance oxygen. If there's 3 oxygen, how many water will I add? 3. Now, by putting water here, I've created another problem for myself. Why? Because I don't have hydrogen on this side, right? So I cannot end this equation like this. I cannot end this equation like, class, for every hydrogen on one side, we use H plus to balance it. We use what? How many hydrogen do I have? 4 times 2. So I'm going to add 8H plus to this side. I'm going to add what? 8H. Class, we use hydrogen proton. H plus means hydrogen proton to balance hydrogen. For every hydrogen molecule, for every hydrogen atom on one side of the equation, we use hydrogen proton to balance it. For every hydrogen atom on one side of the equation, we use what? Equivalent number of hydrogen proton to balance it. What do we use to balance oxygen again, class? Water, H2O. What do we use to balance hydrogen? Hydrogen proton, H plus, right? Class, if you look at this equation now, the atoms are balanced, remains charges. If you watch, we have Mn, we have Mn. O4, 4 times O, O. 8 hydrogen, 4 times 2, 8. All the atoms are balanced, that remains charges. How many charges do we have on the left-hand side? Some of you are just writing what you don't know. Understand first. If writing was a solution, you may write this in secondary school. Change your pattern, you want a different result, change your approach. You just feel like you don't need to write before they clean the board. The writing is useless if you don't understand it. Pay attention. Store things in your brain before your book, class. Your brain is going to the exam. Your book is not going to the... Now, class, total number of charges on the left-hand side. Total number of charges on the left-hand. We have minus 1 charge here, right? 8 times plus 1, we have plus 8. So on the left-hand side, we have minus 1 plus 8 charges. Remember, in ionic equation, you're not just balancing atoms, you're also balancing charges. MnO4 is carrying minus 1. 8H plus is plus 1 but times plus 8. Minus 1 plus 8 plus 7. Use your calculator. Minus 1 plus 8 is plus. So number of charges on the left hand side is plus. Let's go to the right hand side. On the right hand side is plus 2. This guy is on charge, right? On. So on the left hand side we have plus 7. Don't be writing what you don't know. On left hand side is plus 7. On right hand side is plus. What will you do? We need to reduce this to plus 2. Class, we have 7 positive. 7 what? But we need to 1, 2, 3, 4, 5, 6, 7, right? We need only 2 positive to remain. So that I can rhyme with this plus 2 here. We're going to introduce 5 negative. 5 what? Unlike charges attract and kill each other. Minus cancel plus. 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 How many is remaining? So to rhyme with these 2 on this side. So we're going to add 5 electrons to this side. 5 what? If you want to introduce minus to kill plus, put electrons. Electrons are negatively charged. So just use the number of electrons you need. If I had 5 electrons to this side, class, since I have 7, how do I have 7 plus again? This guy is carrying minus 1. 8 times plus 1. So plus 8 minus 1 is plus. But I need to be plus 2 so I can balance ionically, right? I'll add 5 electrons. Each electron is bringing minus 1, 2, 3, 4. 5 electrons will kill 5 plus here out of the 7. How many remaining? You see what the electron is doing? So I'll add plus 5E minus. Plus 5E what? On this side. Let me rewrite this equation very well so you'll not be lost. So the full equation for the reduction is NNO 4 minus plus 8H plus 5A to give what? Mn2 plus 4H2. Class, who remember the time I said we should not put H plus and H2 and they will still come back? I see their back. H plus and H2, they will still somehow find their way back to the equation because when you are balancing an ionic equation, we use them to balance ionic equation. Now class, the 2 oxidation half and reduction half are both balanced, both atomically and ionically. It's now time to balance them electronically. Someone said, now wow, it's not me that made chemistry. It's not me that made chemistry, I'm not the problem. I'm the solution. I'm trying to create solution, not problem. It's not me that gave the assignment. Now follow me. Follow me. Class, let's go. Notice, we will need to combine the oxidation half and reduction half back together. Class, they gave us a complete equation. We want to split it to balance it, right? We must bring it back and return it back as balanced. Before we bring it back, we must do something. How many electrons do we have here? How many electrons do we have here? If we join these equations like this now, we're going to have a problem. We have 5 electrons and we have 1 electron on the other side. We have 5 electrons on the left hand side here. We have 1 electron on the right hand side. to solve this problem, we want to make sure that the number of electrons here is same as the number of electrons here. So when we join the equations together, they will cancel each other. Class, had it been I have 5 electrons on the left hand side here, and I also have 5 on the right hand side here. When I join them together, they will cancel each other. But the number of electrons here and number of electrons here are different. Anytime you finish balancing, and number of electrons on one side is different from the other, you now have to do something. Class, I'm going to multiply this all through by 5, and multiply this all through by 1. Class, number of electrons here is 1, right? I'll take this 1 and multiply this second equation all through by, and take this 5 and multiply this equation all through by what? Just like exchanging their numbers. By multiplying this all through by 5, so we're going to have 5f(a2) plus. Please make sure you're not sleeping now. To give 5f(a3) plus 5 times 1, 5a. Multiplying this guy by 1 will still remain this guy, right? Because anybody times 1 is the same person, right? Having done that, we'll now join these two equations together. Join this and 1 and 2 together. We are going to have understand. It's understand that's making me to teach you without any book. If I crammed it, I will need a book to show you. Understand. When I was in class, I don't need to write too much. I tend to understand the foundation of that concept. There's something that's holding every topic. If you hold the foundation, you get it. After I went to my 2020, no book. You think it's cramming that brought it? It's understanding the concepts. Understand. Listen, watch deep inside. What is it doing? I will do it myself in my book. I don't need to write. I need to understand first. We have been writing since secondary school. Has it worked? Try to understand.
So does that mean that if that one is 2 electrons, we multiply the
God bless you. Yes. Yes. So see this. Join equation 1 and 2 together. Let's go. When joining two equations together, join the left hand side to the left hand side, right hand side to right hand. Class, left hand side of this side, left hand side of this, right hand this side, right hand. So we're going to have. Let's start with equation 1. 5 f(a2) plus left hand. What is it? Plus 5a. We are done with all the left hand. Now let's go to the right hand side. Thank God our board is white. Right hand side, let's start with equation 1 again. 5f(a3) plus 5a plus mn2 plus
4H2O times 1.
no, which one is times 1? Are we joking here? Class, one more thing. Let 5a minus cancel 5a. This wouldn't have been possible if we did not do that multiplication we did. What would have happened is that there would be 5a minus a, there would be 1a minus, and they would have been able to cancel. 5 cannot cancel 1, can they? So that thing we did by multiplying this guy by 1 and multiplying this guy by 5 was what f 5a minus cancel 5a minus. So that whatever is remaining is now our balanced ionic equation. Whatever is remaining is now our balanced